Greetings, Saints. Man, we're going to start lesson 7.3 regarding proving parallelograms. And we discussed some things in class regarding the properties of parallelograms and what's going to be the requirement for us to actually make an assumption about a quadrilateral. And not an assumption, but the facts that we need in order to make a conclusion that a quadrilateral is a parallelogram. So here's some of those characteristics to review from that last lesson that we had. So we're going to write these guys down again. This is that we have the opposite angles are congruent, that we'd have the opposite sides are congruent, that we'd have the diagonal will create, and this is going to be a new one, I think, that will create two congruent triangles. And the reason it does that is through the angle side angle postulate. I'm going to go ahead and just do a quick little illustration for you guys, kind of quick shorthand proof. So here's a parallelogram that we have. Poorly drawn, oh my goodness, poorly drawn, but says parallelogram. I'm going to create a diagonal, okay? And remember, the opposite angle or the opposite sides are going to be parallel. So for either one of these, right, I'm going to have, for example, this diagonal is going to serve as a reflexive side. Moreover, what I'm going to have here is I'm going to have this angle congruent with this angle because those are alternate interior angles, okay? And also the same thing here. Right. So, there we have it. We have, angle side angle, which creates the two congruent triangles. All right. Back to our properties. We have that if we have consecutive angles, they are supplementary because they all function as consecutive interior angles. If you have one right angle in a parallelogram, then you have four. All right, which we discussed, and some of you guys were able to repeat in class, which was great. And again, the opposite angle is going to be congruent in a parallelogram. So if it's a 90-degree angle, the opposite has to be 90, and then the next consecutive angle will be supplementary, 90 plus 90 being 180. So the last one, which I think we're going to really focus on the end of the lesson, is that the diagonals will bisect each other, which is pretty handy for us. I think it's actually the easiest, in my opinion. It's the least amount of work as a test in terms of proving in a coordinate plane the existence of a parallelogram. And then last thing is that we'll have one pair of opposite sides that are parallel and congruent. So this is another way that we can get to this. So I have just a couple examples, and I'll do some illustration of what we were just discussing on the ways that we can do this in a coordinate plane. So in fact, let's do that right now. Oops, my pen died. Oh, goodness, that's not good. Oh, you know what? I would hate to restart this live stream, but this is kind of what we are getting to. Because my pen is malfunctioning here. Oh, there we go. Working again. Excellent. All right. My apologies for that. Let's take our parallelogram here. This is what it's actually saying is that, for example, if we have obviously the two sets of opposite sides, but the other way that are going to be parallel, but we could do the opposite sides being congruent. If we have this, we know that we have a parallelogram, okay? How could we calculate that in a coordinate plane? Well, of course, you could do the distance formula, right? Other ways to go about this. With slope, we could show these parallels, right? Now, here's where it gets kind of tricky is if we have the opposite angles congruent, we don't have any way to calculate the measure of an angle using slope, with the exception of if we are yet. The exception we have here is if we have a perpendicular, we can do that, right? another way to think of this too is it's regarding this guy, diagonals bisecting each other. That's gonna say is that we have these diagonals. It means that this and this are gonna have, it's gonna be a midpoint at that intersection for both of those diagonals. Okay, so one additional way for us to consider this is that if we have the opposite sides going to be parallel and congruent simultaneously, which you could use the slope and distance formulas for just the same side, and they would match in both cases. All right. So we're going to actually consider how to do that. We're going to, in our last example, we'll wind up doing kind of the three different ways with slope, distance, and then midpoint. All right. So next, let's get a parallelogram, do some examples here. We have, this isn't a very good looking one, but it is a parallelogram nonetheless, because I will identify it as that. I have 24 minus x, 2x plus 3, x plus 6, and y. Okay, so the question for our example is, what are the values of x and y that make STU V a parallelogram? So what do we know? Well, we know the opposites are congruent, right? Uh-oh. Pen keeps having malfunctions. Here we go. We know that this and this are going to be congruent, okay? So we know that ST is going to be congruent to UV. So we can just substitute. We'll have 24 minus x. That's going to be equal to x plus 6. And then we're just going to do a little bit of algebra from here, right? We're going to add x to both sides. So I'm going to have 24 is equal to x plus x, which is 2x plus 6. And then we're going to subtract 6 from both sides. So I'm going to have 24 minus 6, which is 18, is equal to 2x. And then I solve for x, which we're going to get 9. Okay? So then now we have that. Since we know simultaneously that TU and SV are going to be congruent, we're going to say that we have 2x plus 3 is going to be equal to y. And then what we do is just we're going to plug in that 9 for the value of x. So we're going to have 2 times 9 plus 3 is y, or 18 plus 3 is y, which will give us 21. Kind of a fun little algebraic thing there. All right. Next up, just 2 more examples here tonight. We have C, D, E, F as our diagram here. All right. And I've got these diagonals. They intersect at M. Okay. And this line right here, CM, is equal to 4x minus 11. And this here, ME, is equal to 2x plus 17. All right. So, question is CDEF is a parallelogram. And what is the value of x? All right. So, if this is the case, if it's a parallelogram, these we know that DF and CE are diagonals. Okay, so let's go back to our initial thing here with these attributes we have here. And the diagonals will bisect each other. So that means that at that point M, CM and ME are congruent. Simultaneously, FM and DM are going to be congruent. All right. So if that's the case, then we know that 4x, or in other words, CM and ME are the same. 4x minus 11 is equal to 2x plus 17 minus 2x minus 2x. 2x minus 11 equals 17 plus 11 plus 11. 2x is equal to 17 plus 11, which is 28. So x is 14. All right. And our last example for today, okay, which is going to be really interesting because I'm going to have a few ways to do this problem, okay? The question is if we have ABCD is a parallelogram, or the question is, I'm sorry, not if, is ABCD a parallelogram? We're never going to draw this thing. We're just going to be given coordinates, which A is the origin, 0, 0. B is 4, negative 2. C is 2, negative 4. And D is -2, -2. Okay? So, let's take a look. How could we do this? Well, we know that AB and CD are across from each other, right? Because it's listed as ABCD. We know also that we have these diagonals. So there's a bunch of ways we could do it. We could do it with slope. Okay? Which we're going to take the slope of these sides. All right? And if the slope of the opposite sides, AB and CD, also, the question is AD parallel to BC? Because we would need both. Because here's here's the thing is it's possible, for example, to have let's say we have this parallelogram. We have these opposite sides that are parallel, okay? But then we have this side right here, which is parallel, and then this side here, which is not parallel. But these guys are parallel, okay? That's possible. Okay? So we have to make sure that both sets are. Let's take a look. AB and CD. So we need the slope of AB, okay, which is -2 minus 0 over 4 minus 0, which is -1/2, okay. We need the slope of CD, which is -2 minus 4 over -2 minus 2. So we have 2 over -4, which is -1/2 as well. So those check out. And then we have AD, which is going to be -2 minus 0 over -2 minus 0, which is going to be 1. Okay. And we need the slope of BC, which is going to be -4 minus 2 over 2 minus 4. So we have -2 over -2, and that's also going to be a 1. So yes, this is a parallelogram. Okay. Now, that's because we proved it because we showed that the opposite, actually, it was the very definition of a parallelogram, right? We also could do it another way. Like, for example, if we did slope, we also could just do it with sides too, being with the distance. So what we need to show, okay, so this is for the slope. Let's do it with sides. So we need to show through 4 distance formulas, which are going to be AB, which would match up with CD, and AD and BC are all going to be being congruent pairs. All right. Now, AD, let's see, AB is, let's see, -2 minus 0. Squared plus 4 minus 0 squared, which is going to be equal to the square root of -2 squared, which is 4 plus 16. So this is going to be rad 20, right? 2 rad 5. CD is going to be -2 minus 4 or plus 4. And -2 minus 2 squared, okay, which is going to be 2 squared, which is 4, and negative 4 squared, which is 16, which is rad 20. Okay. Now, here's actually the best part. We technically have, according to, because we did that slope calculation, going back to the beginning, if we have one pair of opposite sides parallel and congruent, for example, what we'd have here if we did that is we could say that we have AB and CD parallel and congruent, and that's going to satisfy it. And what that's showing is the following, is remember what I described earlier in the video, and why does this work? Okay, why does this show that this is a parallelogram? Well, it's this, okay? Parallel, congruent. Effectively through side angle side, we're going to have congruent triangles, right? And it's going to then show that we have congruent angles that are opposite. Then therefore, it's going to mean that we'll have consecutive interiors that are going to be supplementary, and then therefore we're going to have those parallels, right? So, and here's how it would work with the parallels is this guy, and then we have this reflexive side, which is the diagonal. Okay, so side angle side, congruent triangles. Okay, you may not follow this explanation at all, which means the corresponding parts are going to be congruent, right? Which means I could add these up to get these guys to be congruent, which means these guys are going to be congruent. Okay, showing then that, you know, with the parallel cut by the transversal, we have supplementary angles here and here, showing that those opposite sides are going to be parallel. Okay, or maybe we didn't even want to deal with the slope, and we were back here over with the sides. Well, let's do it with AD and BC. Now these should be the same, right? Because we already proved that, you know, with the sides, the slopes being the same, they're gonna be parallels. So let's check it out with the sides and their distance. So AD, this is -2 minus 0 and -2 minus 0. So this is gonna be 4 plus 4. So this is gonna be rad 8 or 2 rad 2. And then BC, -4 minus 2 squared, and then 2 minus 4 squared, right? Which is going to be -4 plus 2 is -2 squared, plus -2 squared, which is going to be rad 4 plus 4, which is rad 8. Now, I was really messy about this, right? And again, all this checks out for the sides. I was messy about this on purpose. We just proved this now with the opposite sides congruent. Do we have to? Again, we don't need to do that. We've made our point. As soon as one of these is checked off, it fulfills the theorem, and we're set. Okay. But what's the best way to do this? Okay. And this is where I'm going to get at. I'm going to ask you potentially to do this with slope and with distance for the exercise of it. Maybe that's all we're going to be able to have access to. But here's where I would like to show you guys. Oops, excuse me. It's this guy. That the diagonals bisect each other. This is what's nice, because if they bisect each other, it means they have the same midpoint. And we're going to take the midpoint not of the sides, but take the midpoint of diagonals. Okay? You tell me what's less work. Either those first two methods or a combination of the two, or this. Let's take the midpoint of AC, right? First and third. And then we're going to take the midpoint of BC, right? Second and fourth. Skip a letter. I only need to do 2 calculations. Okay? Which is this. AC, it's 0 plus 4 over 2. And then 0 minus 2 over 2, which is going to be 4 over 2, which is 2, comma, -2 over 2, which is -1. BC should be the same exact thing. Okay? I'm sorry, guys. I did AB. Yikes. Mr. Granados. What are we doing here? 0 plus 2, and then 0 minus 4. So this is 1, comma, -2. My bad. Nobody picked that up in the chat. Okay, BC. We have 4. I'm sorry, B, not BC, it'd be BD. First, second, and fourth, right? B, D. for it to be a diagonal. So it's going to be 4 minus 2 over 2, and then negative 2 minus 2 over 2. 4 minus 2 is 2, over 2 is 1, negative 2 minus 2 is negative 4, over 2 is negative 2. Guess what? This proved the same thing. So it's up to you. In my opinion, the midpoint method is the quickest one because it's the least amount of work, because it's the fewest calculations, but it's all a matter of opinion. So good luck, Saintsmen. I will see you in class.